Provided this limit exists, then the derivative of f of x at a is denoted as f dash of a. Differentiation of the function y with respect to x is denoted as dy by dx, and it is represented as f dash of x. This procedure of finding the derivative of a function is called derivative of a function using first principles. If you put x plus delta x is equal to z, then whenever substitutions are taken, the value of limit also changes. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session, I am going to discuss very important concept, that is derivatives, differentiation, second part of the unit 3, that is called derivatives, differentiations. So in this, you are going to study simple derivatives of algebraic functions and the application of derivatives. Just only you are going to study regarding maxima and minima value of a function. That's it. Now derivatives, let us know regarding what is the derivative. Suppose if f is a real valued function, f is a real valued function and a is a point, small a is a point on its domain of definition, that is on this domain of the given function, then the derivative of f at a is denoted as limit h tends to 0 of f of a plus h minus f of a divided by a. If this limit exists, then we are going to represent it as f dash of a. So provided this limit exists, then the derivative of f of x at x is equal to a is denoted as f dash of a. So therefore f dash of a can be written as limit h tends to 0 of f of a plus h minus f of a divided by h. So if this limit exists, then we are going to represent this as f dash of a, that is called a derivative of the function at x is equal to a. Provided this limit exists, then the derivative of f of x at a is denoted as f dash of a. Let us consider, for example, find the derivative of 99 at x is equal to 100. Now before that, suppose if y is equal to f of x is a function, then the derivative of this function is denoted as, if the limit exists, then this f dash of x can be written as dy by dx. So therefore d by dx of y, that is nothing but dy by dx is equal to f dash of x, is called the derivative of a function. This is called the first derivative. Dy by dx is called the differentiation of the function y with respect to x. Differentiation of the function y with respect to x is denoted as dy by dx, and it is represented as f dash of x. Dy by dx or f dash of x. Sometimes we can also represent dy by dx as y dash, or we can also represent it as y1. So therefore f dash x or dy by dx or y1 or y dash, these are all representation of a first derivative of a function. Now let us move on to this. Find the derivative of 99x at x is equal to 100. Now differentiate what is given, 99x. Let us call it as y. Let y is equal to this. Differentiating with respect to x. So dy by dx is equal to your 99 constant. Derivative of x is equal to 1. This is 99 itself. So derivative of this function is 99. That's it. Okay. Now move on to the next. Find the derivative at x is equal to 2 of the function f of x is equal to 3x. Here also, here what is given? Let us take f of x is equal to 3x. Differentiating with respect to x. Differentiating with respect to x, we will get f dash of x is equal to 3 into differentiation of x is 3. Derivative of f of x is equal to 3x is 3. That's it. Right. Now move on to the next very important formula we are going to study. The basic formulas are derivative of a function f at any point x is defined by derivative of a function y is equal to f of x is denoted as f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x divided by h. Sometimes f dash x is also denoted as d by dx of f of x, or it is also called as the dy by dx. dy by dx is called the derivative of a function. So, for any function y is equal to f of x, y is equal to f of x, dy by dx is nothing but f dash of x. This exists if and only if this limit exists. If this limit exists, limit extends to 0, f of x plus h minus f of x by h. If this limit exists, then we are going to represent f dash x as the derivative of the function, or it is also called as the dy by dx. Let us come to the next concept. Find the derivative of the following function using first principle. So, this is called as the derivative of the power function. Power rule. This is called as a power rule of differentiations. This is called the power rule of differentiation. Now, let us see what is the derivative of f of x to the power of n. Now, let us differentiate f of x with respect to x using first principles or by the method of definition. Now, let us consider, let f of x is equal to x to the power of n. Let us represent this as 1. Changing x to x plus delta x plus delta x. Then what happens? This becomes f of x plus delta x can be written as x plus delta x to the power of n. Let us represent this as equation number 2. Now, equation number 2 minus 1 gives, what is equation number 2? Left hand side, f of x plus delta x minus equation number 1 is f of x is equal to x plus delta x to the power of n minus x to the power of n. Now, just divide throughout by delta x. Divide by delta x on both sides. What we will get? F of x plus delta x minus f of x divided by delta x is equal to, this is x plus delta x to the power of n minus x raised to n divided by delta x. Now, this is the first step. This procedure of finding the derivative of a function is called derivative of a function using first principles, or it is also called by definitions. First principles, or it is also called by definitions. Right. Now, next, taking limit on both sides. Taking limit on both sides. Taking limits on both sides as delta x tends to 0. Then what happens? This is limit delta x tends to 0 of f of x plus delta x minus f of x divided by delta x is equal to, on the right hand side, put limit. What is that equal to? Limit delta x tends to 0 of x plus delta x to the power of n minus x raised to n divided by delta x. Here, this can also be written as limit delta x tends to 0 of f of x plus delta x minus f of x divided by. For this delta x, just add and subtract x. So, delta x can also be written as x plus delta x minus x plus x gets cancelled, 0. Here also, limit delta x tends to 0 of, this is x plus delta x to the power of n minus x raised to n divided by x plus delta x minus x. Now, if this limit exists, then we are going to represent this as f dash of x. This is f dash of x, and so this can also be written as, in the previous class we have discussed regarding the limit of, since limit extends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. So, using the concept, if you put x plus delta x is equal to z, then whenever substitutions are taken, the value of limit also changes. So, by just if you put z is equal to x plus delta x, then this limit becomes limit. Whenever substitutions are taken, the value of limit also changes. When delta x is equal to 0, z is equal to x plus 0 is x, z tends to x, right? And this becomes z to the power of n minus x to the power of n divided by z minus x. So, this is of the form limit x raised to n minus a raised to n divided by x minus a. So here z tends to x of z to the power of n minus x to the power of n divided by z minus x. This can be written as n into x to the power of n minus 1. So therefore, the limit of this function is n x to the power of n minus 1. So when limit z tends to x, then this can be written as, so n is n as it is a. What is a? A is x to the power of n minus 1. Nx to the power of n minus 1. This is called the power rule of differentiation. Now, this is very important concept, right? Now, so in general, what is the conclusion? Therefore, the derivative of x to the power of n. So, therefore, d by dx of x to the power of n is always equal to nx to the power of n minus 1, where n is a rational number. N is a positive integer, negative integer, or a fraction, positive or a negative fraction. Very important rule. This is called a power rule of differentiation, right? Let us move on to the problems based on this. Suppose let f and g be the two functions such that their derivatives are defined in a common domain. Then derivative of the sum of the functions, these are called as the rules of differentiations. That is, derivative of d by dx of f of x plus g of x is equal to term by term differentiation d by dx of f of x plus d by dx of g of x. Now, suppose let us take an example for the previous problem, previous formula. Since we know d by dx of x to the power of n is nx to the power of n minus 1. So, let us take an example, d by dx of x to the power of 4. For example, differentiation of x raised to 4. What is n here? N is equal to 4x to the power of 4 minus 1, that is 4x cube, right? Suppose if it is like this, d by dx of x cube. What is n? N is equal to 3x to the power of 3 minus 1. This is 3x square. Suppose if it is d by dx of x to the power of 100. What is n here? 100. X to the power of 100 minus 1. This is 100. X to the power of 99. This is how we are going to differentiate. Now, suppose if the functions are like this, there are two functions. So, d by dx of f of x plus g of x is there, means term by term differentiation, d by dx of f of x plus d by dx of g of x. Similarly, now let us take an example on this. Suppose example, d by dx of x to the power of 4 plus x to the power of 5. Now, this can be differentiated using d by dx of first function plus d by dx of second function. So, here what is n? N is equal to 4 into x to the power of 4 minus 1. Here n is 5 into x to the power of 5 minus 1. This is 4x cube. 5x to the power of 5 minus 1 is 4. Now, suppose if it is like this. So, derivative of a constant, d by dx of a derivative of a constant, so is always equal to 0. Very important concept. Derivative of a constant, we cannot differentiate a constant. So, therefore, derivative of a constant is 0. So, that is d by dx of 2. 2 is a constant, derivative of a constant is 0. Suppose if it is d by dx of root 2. Root 2 is a constant, that is also equal to 0. Suppose if it is like this, d by dx of a, this is also equal to 0, where a is a constant. If a is a constant, then derivative of a constant a is 0. Suppose second rule is there, rule number 2. Suppose if it is like this, d by dx of a constant into function, where k is a constant. If a constant into a function is there, means constant should be kept out. Just keep the constant out and differentiate the function, d by dx of f of x. So, for derivative of a constant into function, constant is kept out and differentiate the function. Let me take an example. For example, d by dx of 10x to the power of 6. What is constant here? 10 is constant. 10 into d by dx of x power 6. So, here this is 10 as it is. Differentiation of x power 6 is nx to the power of n minus 1. What is n here? 6. 6x to the power of 6 minus 1. So, this is equal to 10 into 6 is 60x to the power of 5. So, differentiation of 10x power 6 is 60x to the power of 5. So, if it is constant, derivative of a constant is 0. If it is constant into function means constant is kept out. Let us take one more example. Suppose example number 2. If it is like this, d by dx of 4x to the power of 2 plus 2, 4x square plus 2. Now, how to differentiate this? Here 4 is constant, d by dx of x square, d by dx of x square plus d by dx of 2. So, as you know, a constant into function means constant is kept out and differentiation of x square is 2x plus derivative of a constant is 0. So, this is equal to 4 into 2 is 8x. So, derivative of 4x square plus 2 is 8x. This is how we are going to differentiate using rule number 1 and 2. Now, let us move on to the second rule. What is the rule 2? So, derivative of difference of two functions is the difference of the functions is nothing but term by term derivative of the function. That is, differentiation of difference of the two functions is denoted as d by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x. That is term by term differentiation. So, if it is plus, just put plus. If it is minus, you put just minus. So, in general, d by dx of f of x plus or minus g of x is there, means term by term derivation, that is term by term differentiation, d by dx of f of x plus or minus d by dx of g of x. This is the rule. So, if it is positive, just put plus. If it is negative, you can put minus. Now, let us take an example for this. Example, d by dx of, so x to the power of 4 minus x to the power of 3. So, this can be differentiated. D by dx of, just put x raised to 4 minus d by dx of x cube. What is this equal to? Differentiation of x to the power of 4 is 4x cube minus differentiation of x cube is 3x square. Now, let us take one more example. Example number 2. D by dx of 4x to the power of 3 minus 2x to the power of 6. Now, this is equal to d by dx of 4x cube minus d by dx of 2x power 6. So, here 4 constant, differentiation of x raised to 3 is 3x square minus 2 constant, differentiation of x power 6 is 6x to the power of 5. So, this is equal to 4 3s are 12x square minus 6 2s are 12 x to the power of 5. This is the derivative of the function. That's it. This is how we are going to use sum or difference rules. D by dx of f of x plus or minus g of x is d by dx of f of x plus or minus d by dx of g of x. So, if it is constant into function, just take remove constant out and differentiate the function. Hope you followed. Now, let us move on to the next one. Derivative of a product of two functions. The product of two functions is given as d by dx of f of x, g of x, f of x into g of x, d by dx of f of x into g of x is equal to, here f of x constant, d by dx of g of x plus g of x constant, d by dx of f of x, d by dx of f of x into g of x. So, this is first function and second function. First function constant, f of x into d by dx of g of x, second function, plus second function constant, g of x into d by dx of first function. Right, this is called the product rule. Or we can also write like this, d by dx of u into v, u into v. So, here u is the first function, v is the second function, u into dv by dx plus v into du by dx. This is called the product rule. So, we can call it as u and v. So, u into d by dx of v plus v into d by dx of u. So, this is called as the product. First function into derivative of second function plus second function into derivative of the first function is called the product rule. Now, let us take an example. For example, d by dx of ax plus b into cx plus d. There are two functions. Let us call it as u and v. First function u constant. What is the formula for d by dx of uv? D by dx of uv is u into dv by dx plus v into du by dx. Now, let us write this. First function ax plus b into d by dx of second function cx plus d plus second function cx plus d into d by dx of first function ax plus b. This is an important problem. You may expect this for 5 marks. Now, this is first function ax plus b into, here c constant, differentiation of x is 1 plus derivative of a constant d is 0 plus second function this cx plus d as it is, and a constant, differentiation of x is 1 plus b constant 0. So, wherever d by dx is there, just differentiate at that point. That's it. So, wherever d by dx is there, differentiate. So, ax plus b into cx plus c into 1 is c. So, c into ax plus b plus here cx plus d into a into 1 is a. So, therefore, this can be written as c into ax plus b plus a into cx plus d. This is the derivative of this function. That's it. Okay. Now, move on to the next one. The next important concept is the quotient of a function. Derivative of quotient of two functions is given by d by dx of f of x by g of x. So, g of x into d by dx of f of x minus f of x into d by dx of g of x divided by g of x whole square. This is called the quotient rule. Very important formula. Or we can also write like this, or d by dx of u by v, u divided by v. So, v constant, denominator constant, into d by dx of numerator du by dx minus numerator u constant dv by dx divided by the denominator square. So, u by v, v into du by dx minus u into dv by dx divided by v square. This can also be written as r over d by dx of numerator divided by denominator. Nr means numerator, dr means denominator, numerator by denominator. So, denominator constant d by dx of numerator minus numerator constant d by dx of denominator divided by denominator square. This is also the rule. Any method you can follow to solve the problem. So, different types of representing this quotient rule. So, d by dx of u by v is nothing but v into du by dx minus u into dv by dx divided by v square. D by dx of numerator divided by denominator means denominator constant, differentiation of numerator minus numerator into d by dx of denominator divided by the denominator square. Now, let us take an example on this. For example, d by dx of ax plus b divided by cx minus d. Now, let us call it as u by v. U by v, denominator cx minus d into denominator constant d by dx of numerator ax plus b minus numerator into ax plus b into d by dx of denominator, that is cx minus d, divided by the denominator square cx minus d whole the square. So, this is cx minus d into a constant, differentiation of x is 1 plus b constant 0 minus ax plus b into c constant, differentiation of x is 1 minus d is 0 divided by the denominator square cx minus d whole the square. So, this can also be written as multiplied a into cx minus d minus c into ax plus b divided by the denominator square cx minus d whole the square. That's it. So, this is how we are going to differentiate using quotient rule, d by dx of u by v. Denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. Wherever d by dx is there, just differentiate. This is as it is, differentiation of ax is a, bx plus b, ax plus b as it is, differentiation of cx, c constant x is 1 divided by the denominator square. That's it. Very simple, right? Now, let us come to the results. So far we have studied derivative of a constant is 0, d by dx of x raised to n is nx to the power of n minus 1, And suppose if there are trigonometrical functions, d by dx of sin x is cos x and d by dx of cos x is minus sin x. Suppose if there is an exponential function, d by dx of e to the power of x is e power x. Now suppose if it is like this, d by dx of root x. So what is the derivative of root x? D by dx of root x can be written as d by dx of root x is nothing but x to the power of 1 by 2. What is n here? N is 1 by 2, x to the power of 1 by 2 minus 1, 1 by 2, x to the power of, take LCM, 2 is LCM, 1 minus 2 ones are 2. This is 1 by 2, x to the power of minus 1 by 2. Bring this to the denominator. If x to the power of minus 1 by 2 is taken to the denominator, it becomes plus 1 by 2. So therefore, this can be written as 1 over 2 root x. So keep it in mind, d by dx of root x, derivative of root x is 1 over 2 root x. Wherever there is d by dx of root x, right away you can put 1 over 2 root x. So differentiation of root x is 1 over 2 root x. Suppose if it is like this, d by dx of 1 by x. Now this can be written as d by dx of, take this to the numerator, it becomes minus 1. 1 over a raised to m is a to the power of minus 1 by m. 1 over a to the power of m can also be written as a to the power of minus. What is n here? N is minus 1, x to the power of minus 1 minus 1, minus 1 x raised to minus 2, minus 1. Bring this to the denominator, x square. So d by dx of 1 over x is equal to minus 1 by x square. Derivative of root x is 1 over 2 root x. Derivative of 1 by x is minus 1 by x square. Very important formulas. Now based on this, let us take few examples. So usually in the examination they may ask the questions like this for 2 marks or 5 marks. Differentiate the following. So differentiate the following. First one, if y is equal to x cube plus 4x square plus 7x plus 2. Differentiate this. Now differentiating with respect to x, what we will get? Dy by dx is equal to term by term differentiation, d by dx of x cube plus d by dx of 4x square plus d by dx of 7x plus d by dx of 2. This is term by term differentiation. Now here d by dx of x cube is 3x square plus, you know, for constant into function, constant is kept out, 4 constant, derivative of x square is 2x plus 7 constant, derivative of x is 1 plus 2 constant, derivative of a constant is 0. So therefore, dy by dx, the derivative of this function dy by dx is equal to 3x square plus 4 to the 8x plus 7. So this is the derivative. Dy by dx is equal to 3x square plus 8x plus 7 is the derivative of this function. That's it. Hope you followed. Suppose if find dy by dx at x is equal to 1. Differentiate for the same problem. If they ask find dy by dx x is equal to 1 means, now after differentiating, substitute the value of x is equal to 1. Put x is equal to 1, then you will get dy by dx at x is equal to 1 here. So this is 3 into 1 square plus 8 into 1 plus 7. That's equal to 3 into 1 square is 3 plus 8 into 1 is 8 plus 3. 7 plus 3 is 10 plus 8 is 18. So the derivative of this function x cube plus 4x square plus 7x plus 2 at x is equal to 1 is 18. Right. This is how we are going to find dy by dx at x is equal to 1. Now move on to the next problem. If differentiate 2x minus 3 by 4. Now here this simple problem for 2 marks. Let y is equal to 2x minus 3 by 4. Now differentiating with respect to x. Now dy by dx is equal to d by dx of 2x minus 3 by 4. So term by term differentiation. D by dx of 2x minus d by dx of 3 by 4. So this is equal to 2 into derivative of x is 1 minus derivative of 3 by 4. 3 by 4 is a constant. Derivative of a constant is 0. This is 2 into 1 is 2 minus 0 is 2. So, the derivative of this function is 2. That's it. Okay. Just differentiate it, term by term differentiation. 2 into differentiation of x is 1. 2 into differentiation of x is 1. 3 by 4 constant. Derivative of a constant is 0. That's it. Now, move on to the next problem. If y is equal to x raised to 5 into 3 minus 6 x to the power of minus 9. So, this can be differentiating with respect to x. This is dy by dx is equal to d by dx of x to the power of 5 into 3 minus 6 x to the power of minus 9. So, if you observe carefully, this is a product function, product rule, u into v. First function x raised to 5 constant, d by dx of second function 3 minus 6 x to the power of minus 9 plus second function constant 3 minus 6 x raised to minus 9 into d by dx of first function x to the power of 5. So, first function into derivative of second function plus second function into derivative of first function. This is x to the power of 5 into 3 constant, derivative of a constant is 0, minus 6 into differentiation of x raised to minus 9 is minus 9 x raised to minus 9 minus 1 plus this is constant 3 minus 6 x raised to minus 9. Differentiation of x raised to 5 is 5x to the power of 5 minus 1. So, this is x to the power of 5 into minus plus 9 6 are 54 x to the power of minus 10 plus this is 3 minus 6 x raised to minus 9 as it is 5x to the power of 5 minus 1 is 4. This is the derivative of the function. So, if you do this much, definitely you will get 5 marks. That's it. See, x raised to 5 minus into minus plus 9 6 are 54 x to the power of minus 10 3 minus 6 x raised to minus 9 as it is 5 into x to the power of 5 minus 1 is 4. So, this is the derivative of the function. If you want, you can multiply and simplify also. That's all. This is very important. This is from previous year question paper. Hope you followed. So, these are few problems based on a product rule and the quotient. So, that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.